The wrap up for the third activity that you did on yesterday's lesson. So remember we talked about how the periodic table is all about patterns. You have already figured out some of those patterns. So what pattern have we noticed about valence electrons for main group atoms? And what we noticed is that the number of valence electrons corresponds to the group that the atom or the element is in. So group 1A atoms or elements have 1 electron in their valence shell. Group 5A electrons have 5 electrons in their valence shell. So we can look at the main group, and those are the ones with A's. Main group elements always have the same number of valence electrons as their group, except for the first period. So helium is in group 8, but it only has 2 valence electrons, and that's because atomic number is 2, like it only could have like 2-ish electrons. Now, what pattern did you notice for core electrons for the first 3 periods? So 1, 2, 3. Hopefully you notice that they always have the same number of core electrons. In period 1, I have 0 core electrons. In period 2, every single element has 2 electrons. In period 3, every single element has 10 core electrons. I think I keep mixing up my words. Period 2, 2 core electrons. Period 3, 10 core electrons. So the number of core electrons does not correspond to the period, but it is always the same. Now in period 4, hopefully you noticed a change. The first 2 were 18, and then the last ones were 28. So the question is asked, why does the pattern change? And the answer is between calcium and gallium, we actually have 10 transition metal elements. And notice 28 minus 18 is 10. So that's also why there's this thick line, is that the periodic table really should be split here, and then we insert 10 more columns. So here's a trick for remembering core electrons. What is the atomic number for the last element of the first period? So last element of the first period is 2, and then how many core electrons are in the second period? 2. So notice atomic number 2, core electrons are 2. Let's do a second one. What is the atomic number for, I don't know why I have the written twice, for the last element of the second period? So that is 10. And then how many core electrons in the third period? 10 all the way across. That 10 corresponds to atomic number of the last element of the previous period. And then we do have a change. So what is the atomic number for the last element of the third period? That is 18. And then how many core electrons in the first 2 groups of the fourth period? That's 18. So we've got this correspondence here, and then we already talked about why there's a change when we go from calcium to gallium. So key inference. Recall what period means. And we notice the repeat of valence electrons starts with 1 and ends with 8. So each time the valence electrons reach 8, then you start over again with a new period. So you want to remember this phenomenon, and then also we can infer there must be something special about having 8 electrons in the valence shell.